All right, so in this video, I'm going to go over a technique for switching, or switches in general, called switchport mirroring, or switchport mirrored, or mirrored ports. I'm going to go over what it is, how it works, and why you would even want to use it. In general, what it is the method of copying data from a switch port and sending it out to another specified port. And this lets you capture network traffic, even though it may not necessarily be for you. So let's go over a little bit about how a switch works and why switch port mirroring is a thing. So say you have your switch here, some ports, and keeping with the theme of BMET, let's have our ECGs and our not a server. Let's say it's the central station. So that'll be our the Space Lab central station. Now, each of these machines are connected to a port on the switch, like this. The central station actually has two connections, but we'll not go into that right now. It's for a different reason. Let's just say they all have one connection each. So the way a switch operates normally is it will send and receive data, but it will only send that data to its intended recipient. So, for example, under normal operation, these ECGs in the central station will be passing data to each other. So let's say we have the simulator connected to the ECG, and it's getting trends from that ECG, or from the simulator, and it's sending those trends to the central station. And it's mirroring that. And the way that works is the ECG is sending packets containing this information to the switch, with the intended destination being the central station. The switch receives this information. It compares the hardware addresses, and I'm going to be glossing over a lot on this, but let's just say it's comparing the hardware addresses to the source and destination hardware addresses of the device. So it's coming from this device, it's going to this device. So the switch is going to take that data, send it over to that port, and then send it to the central station. Same is true in reverse. If the central station wants to talk back, goes up to the port, with the intended recipient of this packet being this ECG, it sends it over the internet, or the switch again, and back down to the port for the ECG. One thing you can notice right away is that there's this little, like almost a tunnel forming between this traffic. And because of that tunnel, this port and this port will never see the traffic going through here. They're not even aware of it, that that's happening. And that's how switches are designed to work. It's a more efficient way to use the switch. It causes a lot less problems with things like if they're trying to talk at the same time. This solves a lot of issues with that. And one of the consequences of that, and benefits, is that the switch is only going to send packets to its intended recipient. There's only a certain number of circumstances where that you wouldn't do that. Some are deliberate, some are ones that would be attacks on the switch that would get it to send data everywhere. But by default, they're going to follow this tunnel system and only send data through these channels, sort of like a switchboard for a phone network. So the same way would work with all the ECGs. So these machines are all sending data to each other, sending it to the central station, it's sending stuff back, it's going back to the ECG. So there's all this traffic that's happening between these ECGs and the central station. But our computer over here has no idea what's going on. It doesn't see any of this. It has no clue about this traffic going on here. Now, if there's an issue with this, or we just want to look at the data that's being sent, our PC has no way to do that because it's never going to be the intended recipient of this information under normal circumstances. So the way we could view this information, let me redraw this. Same thing as before, have our switch, which connect to our PC, have our ECGs, and our central station. Now, we want to be able to look at this data either through Wireshark, we want to capture the data in some way to look at it. Maybe if there's an issue with one of these machines, we want to see if it's a network problem. To do that, we have to use a feature called Switchport mirroring. And the way that works is you take one of these ports in the control panel for the switch and say it is now a mirrored port. And then at that point, you would tell the switch, okay, now that this is a mirrored port, whatever port is going to, we define as the mirrored ports, is going to be copied and sent to this PC. So we want to say, well, we want to look at the data that's happening in here. That's where all the stuff is happening. So now when you send data, or when the ECG sends data, it goes up to the switch. And like before, it's probably going to the central station, so it sends it over to the central station, and then sends it for the port for the central station, and sends it to the central station itself. But before that, because this is now set up to be mirrored, it will take this data, make a copy of it, and send it to this port, which then sends it to this computer. Same is true for the central station. If it wants to send some data to this ECG, it will send it over there and then send it down here. But before, because it's part of this group of ports that we're now mirroring, it will take that data, make a copy of it, send it over here, and send it to the computer. And that's true for any combination of this. Any data that's going in or out of these ports at any time, regardless of the context, is going to be copied and sent to this computer. So it's going to get blasted with information. And this computer is in sort of a strange circumstance right now, because it's going to see this data coming in, flying at it, and it's not going to recognize the data. I mean, this PC is not an ECG, it's not the central station, it's not anticipating having all this data, so it has nothing to do with it, so it just drops it. But in the process of dropping it, before it's able to drop it, it must capture the information, because that's just a general design rule of Ethernet adapters, is that they have to accept all the packets that come into them, because otherwise they have no idea what they're for. You can think of it sort of like, you get a letter in your mailbox, and you get the letter, and the Ethernet adapter in this case would be like your mailbox, and the packet would be the letter. And once you get the letter in the mailbox, you've, in all intents and purposes, accepted the packet into the computer. Now the computer would have to look at the packet, its label, and see, is this even my packet or is this something else? This would be like you taking the letter out of your mailbox, looking at the label and saying, no, this isn't my letter. That's exactly the same thing that's happening here. It has to accept the packets and then judge whether or not it needs it and accept or reject it based on that. But because we're running Wireshark, even though this traffic is not going to affect our computer, it's not going to be interpreted by the computer, it's still going to be accepted into Wireshark, which will take the information and display it out in a way that you can view all this traffic that's happening in here on our network. Now, the downside of doing this, you might think, well, why don't you just do this all the time? Well, for one, there's a lot of overhead involved with this. You're copying all of the traffic being sent here onto this port. It's all being sent to this. And whatever poor machine's over here is just going to be blasted with all kinds of information that may not be any way associated with it. So this is only really for special circumstances. In this case, we're just looking at the information that's occurring between these devices. To set this up, I'll like to do another video on this. You have to go into the web interface of the switch and define what is the port that's going to act as the I'm sorry if I'm mixing these terms up, but the mirrored port and then the ports you're going to mirror. And that's a little bit complicated for this. I'll have to do another video on that to show how it's done in the web interface, but hopefully this gives a general idea of how switch port mirroring works, why you would use it, and the sort of pros and cons to doing this. It's definitely not something you want to have set up on a permanent basis unless you have a specific reason why it needs to be set up this way.